Probability standards can be quite challenging for our students. Standard MGSE9 through 12 S.CP.3 is one such standard. In this standard, students are expected to understand the conditional probability of A given B as the probability of A and B divided by the probability of B. Students are also expected to interpret independence of A and B in terms of conditional probability. That is, the conditional probability of A given B is the same as the probability of A, and the conditional probability of B given A is the same as the probability of B. Students encountered probability standards for the very first time in 7th grade, and that is the last time that they've had an opportunity to investigate such standards. In 7th grade, they investigated chance processes, allowing them to develop an understanding that the probability of a chance event is a number between 0 and 1. They represented sample spaces for simple and compound events using methods such as organized lists, tables, and tree diagrams. They used these models to determine the probabilities of events. They also compared the experimental probabilities of the events acquired from their model to the theoretical probabilities of the events. Because the emphasis in 7th grade was on developing a conceptual understanding of probability, students were not introduced to the use of formulas to determine probabilities. One way you might consider opening this standard would be through the CK12 Plix interactive game show with Monty. Plix is an interactive modality that allows learners to play with the ideas in a concept. This modality is all about learning by doing. There are over 1,000 Plix that can be filtered by subject, keyword, concept, or standard. This particular Plix will help students develop an understanding of conditional probability. After they've had sufficient time to debate and come up with their ideas behind this situation, you may consider watching the number file video, Monty Hall Problem, with your students and go through the discussion as featured on that video. In the following clips, you will see students engaged in Part 1 of the Georgia Framework's task, The Conditions Are Right. This is a 3-part task which leads students through a progression of investigations which address the first part of Standard SCP-3. As you will see, this part of the task has students investigate conditional probability through a game that has rules or conditions which include rewards and risk. Through playing the game, students develop a knowledge of how conditional probability can inform them about how one event or factor affects another event or factor, and in turn sets the stage for understanding and formalizing the formula for conditional probability, as addressed in Parts 2 and 3 of the task. The object with Part 1, A Game of Pig, is for students to score as many points as they can after 10 rounds of dice rolls. Your score for a round is the sum of all the dice you roll. You start with a single die and are allowed to keep rolling. If you roll a 6 at any time, another die is added. And if you roll a 1 at any time, your turn is immediately over and your score is now a 0 for that round. You can stop your turn after any single roll, record your score, and move on. As you watch students play the game, listen for strategies that emerge and the decision-making process on when to keep rolling and when to end their turn.
You get two. You get two. Roll it. Just roll a 1.
You have 4 chances to get a 1. Look how good you do. But if you don't get a point, you get so many points. It's over 50%. That's a lot of points.
That's a lot. No wins.
So he stopped his turn.
After students played a couple of rounds of the game, they were asked to reflect on some takeaways or considerations from the game. They were asked to discuss strategies that were successful and least successful, how they change as you roll more than 1 6, and when is it too dangerous to keep rolling, and how would your strategy change if you rolled at least 2 1s at the same time.
I get that 2 1s in a row
because I had like so many dice.
But at the same time, I had one die and I managed to roll like 39.
Yeah, I know you ended up.
I think the best strategy was the more dice you got, you have to hold off on rolling. Don't roll them multiple times. Yeah. Don't take risks with a lot of dice.
Honestly, once we got to like 3, I just took the first one if I got something other than a 0.
So it's good to roll like a moderate number, like 4 or 5.
Yeah, because if you keep rolling, you have a higher chance of getting a 1, and you have a higher chance of getting
On
a
top.
6.
How would you how would it change if you got a 0 if you rolled 2?
Oh, then I would roll 4.
Yeah.
Because it's less of a chance to get 2 1s.
And if you only had one, then if you only had one dice, you could roll until you get.
You can roll until whenever.
The second part of Standard SCP-3 asks students to interpret independence of 2 events in terms of conditional probability, showing if 2 events are independent, the probability of A given B is just the probability of A, and vice versa for B. In other words, 2 events are independent if knowing that one event has occurred has no effect on the probability that the other has occurred. The task Lucky Envelopes from Illustrative Math is an excellent task available to address this portion of the standard. As seen in the following clips, the task builds on students' prior knowledge and understanding of conditional probability established in addressing the first part of Standard SCP-3 and introduces the concept of independence of events. In the task Lucky Envelopes, there are 4 red envelopes, 4 blue envelopes, and 4 $1 bills, which are going to be placed in 4 out of the 8 envelopes. In Part A of the task, 1 of the $1 bills is placed in a blue envelope. The other 3 $1 bills are placed in red envelopes. In Part B of the task, the $1 bills are redistributed between 2 blue and 2 red envelopes, with Event A defined as picking a lucky envelope, which is an envelope that contains a $1 bill, and Event B defined as picking a blue envelope. Students must make sense of the given conditions to answer the probability questions posed in both parts A and B of the task.
A or B. A would have to equal a 50% chance since there are 8 envelopes and 4 have lucky things in them. So we are disregarding the red envelopes completely. So we know that the probability of A getting a lucky envelope given B that you pick a blue envelope would have to equal 25% chance. It's only 1 out of 4 are lucky. I would say it did, because if the envelope isn't blue, if you don't know that it's blue or red, you have a 50% chance of getting a lucky envelope. Knowing that it's blue, however, you would only have a 25% chance.
Is it still the probability of A?
Yeah, the probability of the changes are still 4.
2 blue and 2 red. At random, yes, it would be 50%.
And if 4/8 of the envelopes is still lucky, that's a 1.5 chance as well. So the probability of A given B would give you a 50% chance as well. Because for a blue envelope, you still have a 50% chance of a 50% success rate. In this scenario, it didn't, because you have a 50% chance of drawing a blue envelope, a 50% chance of success with either envelope. So there's no chance. It didn't affect anything really.
In Part C of the task Lucky Envelopes, students are provided with the definition of independent events. They are asked to revisit the conditions provided in the first 2 parts of the task, determine if they are independent events, and then use these particular situations to make conclusions about any 2 events that are independent.
The probability of F is not affected by the probability of E, and the probability of E is not affected by the probability of F.
No, right. No.
So on the one that you chose as independent, which was choice B, is that right?
Yes.
Why did you choose that to be independent?
Because there wasn't
The probability
wasn't
didn't
affected.
change. It wasn't
So the
affected.
probability of getting a lucky envelope on B just straight up was 50%. And then the probability of getting a lucky envelope on B, knowing that you had drawn a blue envelope, was exactly the same. Lucky envelopes is one of several tasks provided by Illustrative Math that address Standard SCP-3. For more information on these tasks and the additional resources available through Illustrative Mathematics, please visit their site at the link provided in the listing of resources for this video.